2016, Microsoft announced the release of Tay, an artificially intelligent Twitter chatbot that the company described as an experiment in conversational understanding. It was designed to interact with internet users through casual and fun conversation, and Microsoft suggested that the more you interact with Tay, the smarter it would become. Unfortunately, it took less than 24 hours for the internet to turn Tay into a racist and misogynistic parrot. This incident raised concerns about AI unintentionally absorbing public prejudice. In another widely publicized story in 2018, a self-driving Uber test vehicle struck and killed a pedestrian while driving at night on an Arizona roadway. The vehicle's AI software classified her first as an unknown object, then as a vehicle, and finally as a bicycle, never as a human being. Clearly, the consequences of unintended and unexpected AI behaviors vary greatly and underscore the importance of understanding as much as we can about what to expect and how much to trust these systems. But how exactly do we go about doing this? Welcome to the IQT podcast. On today's episode, we'll discuss the world of AI assurance by exploring a recent audit that IQT Labs conducted on an open source deep learning tool called FakeFinder, which predicts confidence that a video is or is not a deepfake. I'll be your host today, Vishal Sandasera, and joining me are my two good friends and colleagues at IQT Labs, Andrea Brennan and Ryan Ashley. Andrea is the Vice President of Design and Visualization at IQT Labs and has recently spent a lot of time understanding just what it means to have trust in AI systems. Andrea, welcome.
Hi, Vishal. Thanks for having us. Really excited to be here today.
Yeah, same. And Ryan, you're a senior software engineer at IQT Labs, and you spent a lot of time concentrating principally on cybersecurity use cases, and in this case, particularly how they may relate to AI systems. Welcome.
Thank you. It's good to be here.
So let's jump right into it. We talk a lot about, and people I'm sure have heard a lot about trust, security, AI assurance. Why don't we start with a definition? What does AI assurance mean, perhaps in general context, and more specifically, perhaps to our partners in the USG or the intelligence community, and why is it important? And Andrea, we'll start with you.
Okay, a definition of AI assurance. I might kind of wander around this answer, but we'll try to help you guys understand kind of where we started and where we've gotten to. So I would say that this project really started with a desire to help ourselves and then to help our partners in the government understand what risks do you face when you're thinking about building an AI tool or deploying an AI tool or using an AI tool. So, one thing we know for sure about software is that some of the time, some of our tools are going to fail. And so we just wanted to get a better understanding of what that meant, what types of failures were kind of unique to AI and ML tools, and how could we better understand these different failure modes. And then we hope to kind of turn that understanding into someday some best practices and recommendations for what can we do to kind of mitigate some of the risks. So at the very beginning, kind of before we got into the audit specifically, we started by collecting a number of examples of what we called AI incidents or failures of AI tools and systems that were covered in the public news media. And we actually worked with a partner organization called BNH.ai to do this. But basically, we started by just trying to collect a bunch of examples to help us understand different ways that AI can fail and give ourselves some data to look at to help us understand, what might we be able to do to prevent those failures if we had the right tools. So we can talk more about what we learned from that specifically, but I just want to point out that one thing that stood out to me is there's been a lot of attention recently on adversarial attacks or these kind of specific attacks that are designed to kind of mess up AI systems. And one thing that we noticed in our little survey of these AI incidents was that it was actually a small percentage of the incidents we saw that were caused by malicious attacks. So 95% of the incidents that we saw were due to what we're now calling unintentional failures. So these are just sort of accidents, poor engineering decisions, unintended consequences, basically other types of failures and risks that no one was specifically trying to take down the system, but just things went wrong. So I would say that when we started thinking about AI assurance, the broad goal was to think through what can we do to better understand some of the risks associated with these systems, and then what do we do about that? So how do we mitigate those risks? How do we get out in front of them? And to be clear, we don't have any expectation that we're going to completely eliminate all failures of AI systems or eliminate all risks. But, we feel like it's pretty important to have a better understanding of what might go wrong. What are some of the limitations of these systems? And, at least try to understand what could go wrong before we deploy these systems, particularly in high stakes situations.
Ryan, I have a question for you. When it comes to the topic we're discussing today, AI assurance, how different or similar is it from things that you have done in your past when it comes to things like hardening systems against cyber attack or making sure that things are not as vulnerable to nefarious actors on the internet trying to steal data, for example? In other words, is there anything different to do? Should we think about AI assurance differently than perhaps the branch of software security that looks into cybersecurity in general?
So I think you've asked a really good question, because sort of when we approached this project, I at least, given my background, sort of looked at it a little more operationally than Andrea and the folks over at B&H did. And honestly, at a very high level, no, it's not different, right? Principally, when you're dealing with an AI system or really any kind of computer system and you want to do some sort of assurance on it, you're basically concerned with two things. Is this system being influenced by some external actor for, whatever reason? And essentially, is it operating within spec, right? Is it behaving the way it was designed? Where machine learning becomes different is in sort of the nuts and bolts of that, right? So, for example, one of the standard techniques you'll do to assess some sort of internet-connected system to see if it's behaving within spec, you'll do what's called fuzzing, right? It's supposed to take in a text string of X length, and then you should get some specific result based on the design, right? So you'll run through, strings that are empty, strings that are too long, that contain weird characters, weird encodings, that sort of thing. That's a lot harder to do with machine learning systems for two reasons. One, they tend to take in much more sophisticated inputs in a lot of ways, right? You're not handing them just a string or some kind of data file. You're handing them a video, right? It's much harder to generate every possible video than it is every possible text string of 200 characters. And two, because of the way machine learning systems are designed and built, there's a lot more wiggle room in what constitutes correct output.
And let's talk a little bit about stakes as well. At the top of this podcast, I brought up two relatively recent examples. One in which no human life was lost, and in the second case, unfortunately, in the case of the self-driving vehicle, a pedestrian's life was lost. Is it safe to assume that really the stakes are as high as anything in that spectrum? You could have something that is perhaps non-nefarious and unintentional, not really mean anything, and then in some cases you could have something that actually results in the loss of human life. Is perhaps our thinking around AI assurance going to need to incorporate and allow for different perspectives based on just what stakes are at hand? And Andrea, I'll pose that question to you.
Yeah, absolutely. I mean, I don't know that this is different from traditional software tools, really, but I think the larger issue here is that whenever you're using these tools in a high stakes situation, then it's that much more important to understand the risks, like to understand what could go wrong and what's at stake if something does go wrong. Sometimes the way I think about it is that, the power of AI and ML basically allows you to just increase the scale of what you're doing. So you're not necessarily doing things better. You may be doing things better, but you are for sure doing things faster, and you're able to do things at a much larger scale. So if things are going well and the tool is performing the way you want it to perform, and the predictions that your tool is making or the decisions that you're informing are kind of what you want to be doing, then that scale and increased kind of efficiency of operating is great. But you also run the risk of kind of scaling up the errors that you're making. And so I think that's really, it's important to understand the risks and understand what's at stake anytime you're using any system. But I think one thing that is really different with some of these AI tools is just the scale that's enabled. So it's that much more important to kind of understand what the downstream effects are of design decisions that are made when a tool is being created.
That makes sense. You both recently go ahead, Ryan.
Oh, I was just going to say one thing that is different here is that depending on what kinds of software and hardware systems you're talking about, there's this concept in engineering of a safety critical system. So think about something like the hardware systems on airplanes, medical devices, things of that nature. And those types of systems have a separate set of standards that they're beholden to. And I may be wrong about this, but I haven't seen sort of anything in the way of a robust treatment of how machine learning models interact with safety critical systems. So I think there's an interesting space there that could be filled in the not too distant future.
As I mentioned earlier, you both recently conducted an audit of an AI tool that IQT Labs created called FakeFinder. And shameless tease, for those of you who are interested, I encourage you all to take a look at some of the FakeFinder work coming out of the labs by way of blogs and future podcasts. And during the course of that audit work, you both really had a very regimented and I think very well-disciplined framework that you adopted in terms of how to start to even think about this AI assurance concept and apply it in practice to a real-life tool. I'd be curious to hear a little bit about your thoughts on how that framework is structured and perhaps some of the perspectives and dimensions that you looked into. And Andrea, we'll start with you first.
Yeah, thanks. So one of the things that was really fun about this project was we had never conducted an AI assurance audit before in the labs. So the first step was we had to figure out, what does that mean exactly? What do we mean by that? And how are we going to go about doing this? And so basically what we decided to do was, well, first of all, I should say that in trying to get our arms around this concept of assurance, we felt it was very important to conduct an audit. So we didn't want to just kind of spend our time thinking about what we could do. We wanted to force ourselves to come up with an audit approach and then carry out an audit to kind of test out our ideas about how we would go about kind of understanding these risks. And, that's, as you know, kind of a strategy that we use in the labs in general. We try to force ourselves to do something and to have kind of put our own feet to the fire, I guess, to hold ourselves accountable to some of the grand and sweeping ideas that we come up with. So I think that was really helpful in this case because we learned a lot from going through the steps of actually doing the audit. But at the outset, we decided to use something called the AI ethics framework for the intelligence community as a guide. So that helped us a lot by providing a number of different topics, but also many different questions within those topics. That gave us a sense of just the scope of things that we might look at in our audit. But then just because of the logistics of how this project came together, we only had 3 months to conduct the audit. So looking at that AI ethics framework for the IC, we knew that that was far, far too broad to be able to address all of those questions in a thorough and rigorous way in this 3-month period that we had. So basically, we then made some decisions to focus on just 4 aspects or 4 perspectives for our audit. So we basically did a cybersecurity audit, and that was addressing a lot of the issues that Ryan spoke about before or kind of mentioned earlier. We wanted to look at bias, so the question of bias in our audit. So, were there undesirable types of bias in the outcome or the output of the tool? And what might that mean if the tool were kind of used in real life or in practice? Then we did an ethics assessment. So we wanted to try to think through what are some of the ethical implications of using this tool in a particular workflow or particular scenario. And then we also did a user experience audit. And for that, we were really looking at where are the possibilities for a user of this tool to misunderstand the results that they're seeing. And then I should say that we also decided at the outset that we wanted to audit a tool that had been developed in the labs. So, and we did this because we were thinking about how to stand up kind of a red team or an auditing team within IQT Labs. And so the tool that we decided to look at, you mentioned at the top, is called FakeFinder, and it's a deepfake detection tool. So it's a tool that uses several deep learning deepfake detection models, and then has kind of a user-facing interface that shows the predictions of those models. Basically, you can use this tool, FakeFinder, to upload a video, and what you'll get is a set of predictions from these detector models about whether or not the video is fake.
Ryan, when it comes to, so Andrea mentioned 4 different sort of perspectives or dimensions that you looked into during the course of this audit, and I want to key you in a little bit on the cybersecurity portion of it and direct this question to you. In your experience, when we think about the traditional cybersecurity attack chain or kill chain, how different was your work with the specific audit work with FakeFinder in terms of detecting vulnerability or figuring out surface area for attack as compared to, say, things you've done traditionally when you're looking at a cybersecurity kill chain and addressing vulnerability in that context?
Sure. So the kill chain is interesting here because, like I say, the machine learning stuff seems like it would make that different, but it really doesn't, because the kill chain is just a process, right? I still have to conduct all of those steps. I've got to do recon, right? I've got to see what systems I have running, how they're talking to each other. I have to establish a foothold, right? Once I've got that foothold, I've got to then use that to either move laterally or vertically, right? Elevate permissions or move into different systems. At various points, I was able to do both. And establish persistence mechanisms. It's at least part of the way that I thought about this was that I made a conscious decision to treat this in the same way that I would any other computer system, right? Because your adversaries aren't going to treat it differently. They're not going to be like, oh, this is a machine learning system. We have to do something different. What they want is access to your data, access to your organization. They want to influence your outcomes, right? And so I took that mindset and approached it in that fashion and said, I don't really care what the components are. I just want to get in here and see how I can use those components to achieve my ends.
That makes sense. Andrea, in addition to the 4 optics that you laid out as part of the way you all assessed AI assurance in the FakeFinder audit, is there a 5th or 6th or 7th that perhaps if you had more time you would have considered as far as additional dimensions?
Yeah, that's a great question. So Ryan and I have been asking ourselves this recently because we are currently we're kind of setting up for our second audit. So looking ahead, we're planning to run another audit of a different type of tool. And part of why we're interested in doing this is to kind of test out the methodology that we used to help us understand how generalizable it is. And so one thing that we've been talking about is, these 4 kind of high level perspectives, we think are really important, but they're certainly not the only things that we could have looked at. And so a couple other things that we've been thinking about focusing on in our upcoming audit are kind of the issue of explainability or transparency. So this is something that we've looked at in the past in the labs, but I think this continues to be a real challenge in some of these machine learning and deep learning systems. So when you get a prediction or a result from the system, how do you know why, or what can you tell about, like, what were the important conditions or features that led to that prediction? Sometimes this is really important, especially if there's an erroneous prediction that gets made that is then later acted upon, right? So no one really cares that much about, transparency, maybe if everything is going well, but if the machine kind of makes a bad prediction and someone in the real world acts on that, then suddenly there's a lot more demand for, well, where did that come from? What led to that? Either from just a perspective of like, how do we fix that so we don't have that kind of error in the future? Or also, if things escalate to kind of a legal scenario, then that kind of accountability becomes really important. So we're thinking about explainability. I think there's also I was just going to say the other thing that I think is kind of important in terms of explainability from this standpoint, when you start talking about things like bias and ethics, and you'll know this as well as I do, Andrea.
In the world of user experience, there's sort of the whole realm of like basically how the user perceives the system, right? I'm thinking the idea that a system can take longer to load, but if you give it some kind of progress bar because the user can see that, they think it loads faster. And that leads directly to me to this idea of sort of fairness of a system, but also perceived fairness of a system. And I think explainability has a big role to play in that as well.
Yeah, absolutely. I mean, part of AI assurance is making sure we understand more about the limitations of these systems. But I think, to Ryan's point, part of assurance is also helping people who are future users of the systems have the information or the context they need to feel comfortable using these tools. So part of it is about developing trust, I suppose, like developing trust in a system or giving people the assurances that they need to feel comfortable. But hopefully only when that trust and comfort is warranted, right? Like we don't want to artificially help people trust a system that shouldn't be trusted. So I think both things are important. Another aspect of assurance that we didn't look at for FakeFinder, but we certainly could, is data privacy and the many concerns around that. And I'm sure there's other things we could look at as well. But again, we had kind of 3 months to do this initial audit, so we had to make some decisions about where to start and how to focus. And I think the places where we did focus, I think are very important and like are kind of critical aspects of an assurance audit.
It intuitively makes sense to me. I read through the report, the audit report that you all constructed, and it intuitively makes sense to me, and it further drove the impetus for what I think should be a fairly mandatory practice in AI systems creation. By both of your assessments, and Ryan, we'll start with you. How do you think the industry or our partners in U.S. government are heeding this concern or this warning? In other words, is AI assurance becoming, or is it already a pretty big part and practice of AI system development, implementation, and delivery? Or do you feel that it's too nascent right now and perhaps it's not nearly as widespread? The practice of conducting these types of audits to work towards assessing trust are not as widespread as they ought to be. And again, Ryan, we'll start with you.
That's an interesting question. I think that the sort of the adoption of these assurance ideas in places is sort of driven more by business needs than anything else, right? Like, I'll take the easy way out and throw Facebook under the bus because Lord knows they seem to be good at it. In a place like that where you're primarily looking at sort of a profit motive and a business end, then this sort of assurance thing, is this fair? Is this ethical? Comes a lot later in the process, right? Whereas I think when you're talking about something more complicated, like I can imagine a lot of government use cases, they're going to want to be able to justify this to, the public, to regulators, Congress, so on and so forth. And so that assurance piece becomes a lot more important. One data point that I found interesting, I just read about this recently. I guess Amnesty International is standing up a lab dedicated to, what do they call it? It's like the AI accountability lab, algorithmic accountability lab, something to that effect. And I just thought that was kind of an interesting data point in this space.
Interesting. Andrea, same question. Thoughts?
Yeah, I think from what I've seen, it really depends on the industry. So certain industries like finance comes to mind, specifically lending. There are very clear regulations that I think big banks are used to having to audit their tools in light of these existing regulations. And the introduction of machine learning into those workflows, it doesn't really, like the machine learning models have to get audited just as like a conventional type of model would, because the banks are held accountable for ensuring that they're upholding fair lending laws, for example. So I think one thing I've seen is that there's a lot of variation in terms of auditing of machine learning tools depending on the industry. So I think industries like lending, where there are existing laws, you see much more kind of robust standard auditing practices. That said, I mean, I think in the last couple of years, there's been a lot more public scrutiny of some of these tools. There's a lot more media attention focused on what could go wrong. And there does seem to be a lot more interest in AI governance, AI accountability, fairness, bias. So I think some of this also just comes from the maturity of the tools, right? When most of the AI and ML tools are kind of in a research lab context and they're not necessarily impacting decisions that affect people's lives as much, then maybe there wasn't as much focus on auditing and ensuring the accountability of these systems. But now that we're seeing more of these systems be deployed at a large scale, I think there's much more attention on like, okay, well, who's accountable for, if a software development team creates a machine learning system that gets sold to an organization and that organization uses the system to make a decision that affects someone's life in a negative way or has kind of leads to discriminatory practices, how do you litigate that? Like, who's responsible, who's accountable? I mean, I think some of this is going to get sorted out just in like a series of civil lawsuits, right? And we're kind of just at the cusp of that. Like, we're just starting to see these things happen. But I think over the next several years, there's going to be a lot more emphasis on auditing because there's just going to be a lot better understanding of some of the business risks of deploying a system before you really understand what could go wrong.
Yeah, that makes sense.
So
Andrea,
something you just said, Andrea, kind of gave me a thought that I want to put out there to you guys, which is, you mentioned lending in finance as an example. I think the flip side of that would be an equally interesting case study. What about sort of the models involved in algorithmic trading, right? And so I think rather than thinking about it in terms of industry, what we're really talking about is sort of risk tolerance, right? The consequences of, just losing money versus sort of the regulatory reprisal that you're talking about in lending. Creates a very different way of thinking about these sort of things. And I think that's a useful way to think about it, I guess.
Yeah, absolutely. So to be clear, I mentioned, okay, so I think that we are seeing more emphasis on auditing or companies that have auditing practices that are more mature when there are existing regulations. That's just something I've observed. One would hope that the higher stakes the system is, or like when you have situations where people's lives or health and safety are at risk, that you would see more robust auditing practices. Hopefully we're getting there. I mean, I think that is the case in the government, right? I think the US government tends to be maybe more risk averse than a lot of private companies that we think about. That's a very, very general, like, blanket statement that it's certainly not true in all cases, but I think that has to do with kind of the way that different organizations operate and what their risk tolerance is. So yes, absolutely. I think we should be thinking about auditing more robustly when the stakes are higher. I don't know that that's always been the case to date, but hopefully that will be going forward.
And should it be the case that the purpose of an audit, and this is an opinion, Andrea's opinion, Ryan's opinion is what I'm asking for here on this. Should the point of an audit be to wait until all risk is removed or a certain large amount of risk that is identified a priori be removed, or is it more for transparency, or is it about striking a balance? In other words, what should be the goal of someone an organization that decides to undertake the effort to conduct an audit? Is it to say, hey, let's stop deployment or let's stop production until we have identified and de-risked? Or should it be more so, let us understand and attempt to mitigate as best as we can and still move forward? Andrea, we'll start with you first.
Yeah, so I don't think it's possible to eliminate all risk when you're talking about any kind of system, especially with emerging technology, because I think it's nearly impossible to anticipate all future uses of a new technology. So therefore, it's going to be nearly impossible for anybody involved in kind of the early stage development of a system or even the deployment of that system to foresee all possible things that might someday go wrong. That said, I mean, I think there's certainly an organization does have some responsibility to make some kind of concerted effort to identify likely modes of failure and take actions to kind of remediate those as best as possible. And you would want to do this not just from an ethical perspective, but also from a business risk perspective, right? Like you want to try to de-risk these systems so that you don't find yourself in legal jeopardy once you release your tool. But I wanted to say too that this is part of why we felt that doing an ethics assessment was a really important aspect of this audit, because that I think helps us make decisions about which types of risks are okay and which ones maybe should result in, a decision to hold off deploying a system. So part of what we did in that ethics assessment was think through who are different stakeholders who might be affected by the use of a system like FakeFinder, and what is at stake for them? And also, what is at stake for them if something went wrong? So we tried to do that kind of thought exercise in a rigorous, structured way to help us get a better understanding of what could go wrong for what different types of stakeholders or groups of stakeholders. And that kind of helps us think through like what types of risks are acceptable and which ones aren't.
These sorts of risk assessment exercises are very common in cybersecurity. And the thing that I would add that industry does that I don't think Andrea mentioned is mitigation planning, right? So here are the risks that we know about. Here's what we think their likelihood is. If these things happen, here's how we will go about reducing the harm that can be done.
That's great. Let's shift gears for a moment and talk a little bit about opportunities and challenges, specifically for our listeners who may be either in the IC or sort of in the U.S. government space. Andrea, from your experience and the things that you've seen in relation to the audit work that you've done and sort of your understanding of the process and the effort, what would you say to someone that's in USG or in the IC that's perhaps considering adopting, developing, or deploying an AI system, specifically in relation to how they might want to think about audit or how they might want to think about assurance more generally?
Yeah, so I mean, based on the experience that we had kind of going through this exercise, I think that some version of this should become standard practice before these tools are deployed. And I say that while recognizing that it's a huge lift. I mean, it's just a huge amount of work. And I think one limitation that Ryan and I are very aware of is that, we went through this audit and it was a fairly manual process. Like we used some tools to kind of help us, but there's still just a lot of person hours required to kind of think through all of these things. And we also felt it was very important to collect input from a lot of different stakeholders. So there's just a lot of people that kind of need to be consulted and should be kind of part of the decision-making process. And I understand that that's not always realistic and very difficult to orchestrate, and it doesn't seem feasible to do that for every machine learning model. I understand that the difficulty of that, but at the same time, especially when these tools are deployed in situations where people's lives are potentially affected and there are like significant downstream effects that are possible, I just think we have to get a better handle on what's going on in these systems. I think it's very tempting to think that AI tools and machine learning tools are they're like making things more efficient and there's all this upside, but we just really need to make sure that these tools are doing what we think they're doing. Like that's, I think, the biggest thing for me that's come out of this audit is like, we're not going to eliminate all risk. It's great to have a risk mitigation plan. It's great to just think through what would we do if this went wrong. It's great to get the lawyers involved in thinking through that so that you're not kind of caught off guard if something does go wrong. But I think more than anything, I think we just need to make sure that these tools are providing the information that the people using the tool think that they're getting. And, you know, to go back to kind of the UX portion of the audit, this is just something that, I think is really important. Obviously, I come from a design background, so I'm a bit biased in this regard, but I think so many of these tools, they aren't always super transparent about the ways in which the results or the information that they generate has uncertainty embedded in it, or has kind of the potential for different errors. And so one thing that I think is just, I can't overstate how important it is just to help the users of these tools understand what they're really getting. Like, what is the information that's really coming out of these things? And there needs to be kind of a lot of thought that goes into the workflow around how this information is used in practice.
That makes sense. Ryan, any thoughts from you?
Yeah, I would follow what Andrea said there with sort of that keeps going, not just in terms of workflow, but sort of how you present it. I don't know if we've actually talked about it yet, but sort of precision language is kind of very important, because one of the things that we flagged in our report, and I don't think we've mentioned it yet, is that we keep talking about FakeFinder as a deepfake detection tool, but it's not a generalized deepfake detection tool. It's actually looking for just this one very specific subset of deepfakes called face swaps. And so if you handed a video that doesn't have a human face in it at all, it literally just does nothing with it. Some of the models will actually crash. So the other thing that I would say in that vein is one of the topics that I've been thinking a lot about in recent years is right now these models are very much the domain of people who specialize in developing these models, right? So again, if you go back to the analogy with other software, in most software you have sort of two different groups of workers, right? There's the development workers, the people who build the software, and then there are the operations teams, right? The people who keep it running, apply patches, that sort of thing. Right now in machine learning, there's really only the development aspect of it. And I've been thinking a lot about, like, how do we build out the tools and the techniques so we can turn this over to an operations team and they can keep it alive in a long-term way.
And I'll share my perspective on the matter as perhaps a consumer, from a consumer standpoint. A lot of these tools, a lot of the things that I interact with on the internet especially, and now to include devices that are either on my person or in my house, I put blind faith and blind trust into, and largely I've been fortunate enough not to have been burned by or harmed in any which way or maimed or hurt. But it gives me great relief to know that smart minds like yourselves, Andrea and Ryan, are looking into this. And I certainly hope that there's a larger and wider adoption of the principles and the frameworks that you've used and that you've exposed FakeFinder to, sort of across the industry. Organizations that are building and deploying these things. I have hope, and I'm encouraged by the fact that you both have looked into this, and it certainly seems like it's a point of topic and a point of interest for a lot of folks that you've encountered, means that as far as our human interactions with AI, we look for a brighter and safer future. I think our time is drawing to. Go ahead, Andrea.
Oh, I was just going to make one last comment there. So I think that, we've talked a lot about auditing a tool before it gets deployed or before it's used. But my hope is that some of these kinds of tests that we ran as part of our audit become standard in the process of developing models. And so I think one of the challenges right now is that a lot of teams who are building machine learning models, they tend to optimize around predictive accuracy. And that makes sense, right? Like, you want to build a model that's going to give you the most accurate predictions possible. And I'm not questioning that. I mean, like, obviously we want high predictive accuracy. That's why we're building these models in the first place. But that's not the only thing that we need to look at. So we're planning to do another podcast in the future with the folks we worked at with B&H to talk specifically about the bias testing that we did on FakeFinder, or on FakeFinder's deepfake detection models. But I think that's a great example of just another thing that we need to look at when we're developing models. So it's not enough to know that you have high predictive accuracy in general. You also want to look at how the model performs across different aspects of your data, right? So, and this becomes very, very important when the data that you have involves humans or, images of humans. So for FakeFinder, one of the things that we wanted to look at is, like, how does FakeFinder perform when you have videos of people from different ethnic or racial backgrounds or different genders, right? And so in addition to having high predictive accuracy overall, you want to make sure that there aren't drastically different types of behavior from the system when you have different groups of individuals, because that's where you can get some bias and potentially discriminatory outcomes. So I think some of this comes down to, like, changing some of the metrics that we use to evaluate the performance of these systems from a design perspective.
That makes sense. And to Ryan's earlier point, I certainly think setting expectations, a big part of, I think, establishing trust in these AI systems is clearly communicating what the system is capable of actually telling you. In other words, in the case of the face swap example, it might be the case that referring to the system as a face swap detector might be more accurate than referring to it generally as a deepfake detection tool, at least in its current incarnation. So certainly valuable input there. Ryan and Andrea, I want to thank you both for your time today. This has been extremely informative and very educational. I want to encourage our listeners to learn more about this topic. I know both of you are currently working on and will soon release other content associated with this topic, blogs. I know, Andrea, you mentioned that a future podcast with our colleagues and partners at B&H in relation to this topic, and some more about the audit work that you all conducted together will be coming out. So I encourage our listeners to stay tuned and keep an eye out for that. And before we close, I wanted to give you both an opportunity to leave us with any key takeaways, and perhaps I'll see the discussion, just to bring a little bit of levity to our conversation. If we're headed towards a Skynet, I'm glad that Skynet perhaps will be assessed to be as least harmful as it possibly can be for all of us as humans. Any additional thoughts from either of you?
Yeah, so I think one of the most interesting kind of high-level findings from this work was, we did the audit and we had a lot of specific findings about FakeFinder. We wrote up, an audit report that kind of details what we found. But again and again, something that we ran into over the course of this project was just the different mentalities that we encountered when we talked to some of the data science folks and engineers who were involved in developing the system versus talking to lawyers or people thinking about the privacy implications of the system, right? And so I think one of the things that's really interesting about this topic of assurance in general is that it kind of forces a lot of different people with different types of expertise to kind of wrestle with similar questions. And so it's been really interesting to see how forcing some of these questions about risk and bias and ethics, it just inspires people to kind of ask different questions about the system and think about it from a different perspective. So, it requires like a very different mindset from just kind of building a technical system to try to perform as well as you think it can, right? It's just introduces a lot of other types of issues, and some of them are quite thorny and complex and don't have easy answers. But I think it's just good to realize, like, when you deploy these tools in a real world scenario, it's very hard to avoid like hitting up against all of these like tricky, thorny, complex social and human problems.
Any thoughts, Ryan? Or are you good?
Oh, I mean, I have so many thoughts. I'm trying to think of which ones I can say without getting in trouble. No, I mean, for what it's worth, I think that this idea of sort of continuously evaluating and monitoring these things is going to be a huge growth area, right? I can't wait to see the kinds of tools and things that come out so that people can keep tabs on this. So just as a bit of an anecdote, one of the things that I did sort of in the wake of this was try and remediate some of the things that we found. And in doing that, I made some changes to dependencies, and that actually changed the output slightly, right? So it becomes an interesting question of at what point do these engineering trade-offs become sort of game breaking, right?
Yeah, I think that's a really good point. That's something that comes up again and again in this work is just when you have these phenomenally complex systems, there's just a lot of risk associated with that. And so, I'm not very popular for bringing up this point again and again, but I think it's always worth kind of questioning the value of that you're getting for all of the additional complexity. I guess trained as a designer, I'm always sort of asking, well, what is the simplest solution that can give us 80% of what we need? And sometimes I think that's a good strategy. Sometimes I think that's a better way to go than the much more complexity to try to get from the 80% solution to the 95% solution.
I think that's a great way of thinking about it.
There's an interesting corollary there too that I kept running into in this work, which is sort of a false sense of simplicity, right? Where somebody does something that's 1 or 2 lines of Python code in one of these models, and it looks very simple. But then you actually dig in under the hood, and you find out, no, that's because a very, very smart person went through and papered over a bunch of the complexity for you in this other library 3 layers down. So you thought you were doing something simple, but you were actually doing something fantastically complex, and you may have created new problems in doing so.
Yeah, well, incredible how this concept of transparency transcends even just the communications bit about setting expectations around what is it that these tools can do. Getting a clear sense of how they're constructed, I think, sometimes is a befuddling activity as well, as Ryan has just alluded to. Andrea, Ryan, thank you both so much for your time. I certainly appreciate it. To our listeners, if you're interested about this topic or the wide world of other interesting topics that we spend our time and our brain energy on at IQT Labs, I encourage you all to check out iqt.org/blog for some of the latest coming out of IQT Labs. And again, I encourage you all to stay tuned for our next episode when we host guests from B&H.ai to further discuss the ethics and bias. I encourage you all to stay tuned for our next episode when we host guests from B&H to further discuss ethics and bias surrounding AI assurance. Thank you all for listening. And again, Andrea and Ryan, thank you for being our guests today. Till we talk again, take care.